Okay, what we have here is my hand rendition of a boiler system, hot water boiler system, not steam. Just to go over some of the basics, we have the boiler here itself. Here's the circulator pump is taking the return water into the boiler, sending it back out to the system. I'll explain this part here. So we have the pump. Here's our pressure reducing valve. Here's our backflow preventer so the water doesn't get back into the domestic water if for some reason or other we had a pressurized system here and the house had no pressure on it whatsoever. We have an expansion tank, and I'll review all of this stuff later, but I just want to point it out. Here we have the relief valve set at about 30 psi, and that pipe is supposed to be 4 to 6 inches off the floor as a minimum. If for some reason or other this thing is blasting away, you don't want that steam or hot water just blowing out. I will take this gravity feed. Since water rises on some of these systems, we'll have this gravity feed here that will stop convection from going into the system when the pump is off, because it's going to be hot. And that actually happened on a job I installed. Didn't have one of those, and with convection, the baseboards kept getting heat even though the thermostat was down. And this has to be like a little brass item, so when the pump comes on, it lifts it up and lets it go ahead. And that would be right here on top of the boiler. Reason I have a star here, this is RTFM, read the freaking manual, because depending on the manufacturer as to whether they want this pump taking return water into the boiler or be on the outside sucking the water out. So you should read the manual, because that can have ramifications if you don't do it. Here's an illustration of the air scoop that the water would come in. I usually put them in the return. There's less velocity. The water would come in. The scoops would catch the air and have an automatic air vent getting any air out of the system, and it would continue on. Here, I just bumped the thing. This right here, call it a purger system. This should be in a baseboard system, one in each return line from each zone. Okay, and what would happen? Normally, it would be just there and not doing anything. But if you had air in the baseboards, and the baseboards will say go across the room and then down under in the basement back up again, because there's a door right here. So any one of these areas where the baseboard is could get air into them, and if there's air in the baseboards, the water will not circulate. The pump, if everybody ever heard these things where if somebody shoots intravenously and get air bubbles in your vein, that can get in the heart and kill you. So it will not let it go there. So we have to get water out of the system, and we used to have little bleeder vents on the return line of each of those baseboards. Well, if you have these in the system, what we can do is we can close this at a little ball valve. I close it, it shuts it off here, and I put this and I hang a bucket here and open this up. Just sort of like when you get air out of a garden hose in the springtime, you turn it on and that air gets all the air out of the system. So when you do that in the zone you're working on and it comes out and it's coming out hot, then you can go ahead, close this, open this back up again, and then you got circulation through. So you can bleed it in a short period of time. Do not put like a 25-foot hose on here, because first of all, you can't tell, how much you're bleeding out, and not only that, it can have enough resistance where you don't get the flow. You do have to watch the pressure gauge on the boiler to make sure you don't take it down too low, because the automatic fill vent, the pressure reducing valve, has got to make up the water that you take out. So you may have to sit there and stop 2 or 3 times. I had one house that had 5 zones. We had to do that, on the zones. And say one time, 2 out of the 5 zones didn't work, and so I just purged out the 2, and then everything else worked okay. Up here at the top, I have just a diagram of what a radiator system would be like. The pipes would be in the basement, and the pipes would come up through the floor into the radiator, and out of the radiator. And right here would be a little bit itty bitty manual air vent. Maybe when I do another video, I'll show that. So that would be there, and some of them would be on the first floor and second floor, etc., etc. One way that you can tell, there's a lot of things that you have to learn when you're working with this stuff. You could have a radiator, say, in little Johnny's room, and then the people say everything's fine except Johnny's room, the radiator's not heating. Well, you could have just a trickle of water going through there, and a lot of times it happens in the second floor. This could be half full of air. And you would open up this air vent, the pressure in the system would bleed the air out of it, so you get all the air out, and the water goes through, then you close it up, and it's going to work. I have here a sample of a hot water baseboard system where you have the pressure going in, and we have zone valves here, so I can control this zone with the thermostat or this zone with the thermostat, and you can have, like I said, up to 5 of them, and going through the vents coming back, and you'd have balancing cocks. So if this was all on one loop, you'd want these to return water at the same time. Sometimes people have the front of the house on one loop and just all on one zone, but one loop, and you want to balance those out. Here's an example of coils in air handler units, say on a commercial situation where you would have a 3-way valve that normally the water would come through the valve and go back to the return. This is sort of like our building. These represents the air handlers in our building, and the boiler in the technical building is what, a couple hundred yards, well, probably more than that, but a quarter mile down on the other part of campus. So if the water stopped, it's just like waiting for your shower to get warm when you turn it on in the morning. So this water is circulating there, ready to go. The thermostat moves this valve and starts putting the water through here, and it works on chilled water or hot water, and that's how a lot of commercial buildings are. And I think I may have covered everything on there. I have about 1 or 2 minutes. I want to make sure that I've done everything. I'm going to give you a picture in the book that shows a bypass on the boiler. I don't remember the page number. A lot of the new high efficiency boilers have very, very little water in them. I mean, maybe a regular boiler might have 15 gallons of water in there, and that's quite a bit. But these are the small high efficiency 90% ones have very, very little water. And what they have to have is a bypass going here. As soon as the water gets warm, some of it comes back here to keep this boiler warm. You can have a boiler like this doing a great big house in Chevy Chase with all the radiators. This water coming back here is cold, and then the condensation from the flame gets in here and can actually do damage. So that is a typical thing happening on high efficiency boilers, or even older boilers that are only putting out, say, 140 or whatever degree water. You can still get condensation, which can ruin the boiler. So this is quite a common thing. Some of the boilers even have it internal where you don't have a control over it. I think that is probably all that I want to go on here. I'm going to stop this video and start another one on the steam because it gets to be too big of a thing and I can't attach it. So be back shortly.